continue on to look at WSDL. So SOAP is only a way by which you can, it's a specification for messaging, right? It's a specification to say that this is how messages shall be constructed and this is how messages shall go from one place to another. But what we are actually worried about is exposing our services, and how do we expose the services in a standard way that is independent of language, independent of operating system details, whatever, independent of the implementation, in other words, right? So that anybody on any kind of a platform on the other side will be able to use it. So that's the answer to that is the web services description language, right? And that's called WSDL in short, and so we'll quickly go through this agenda. We don't have to spend time on seeing what the agenda is. So what is WSDL? So it's an XML language. Like I said, XML underlies all of web services. This is also an XML language, and it describes the service specification itself. You know, what do I offer as a service? How can you bind to me? How can you contact me? Right? Once I say that you can bind to me through SOAP HTTP, then the rest of the protocol specification for SOAP kicks in, and you will contact it in that way. Right? So it's actually described as a set of communication endpoints. We'll see what the detailed structure of a WSDL message is. But there are two parts to it. So every WSDL document which exposes a service has two main parts. One is a set of abstract definitions of what is it that I can accept as a message. In other words, I am doing a tax calculation service. Right? That's an abstract description regardless of how you contact me. I am doing this service. Right? So that is the first part of it. Next one is a more concrete binding. Given that these abstract definitions exist, they can be reused. It's like an IDL specification for Corba. It's just an interface. This is my interface, right? And that can be reused for multiple concrete bindings that you can create. I will listen to SOAP or HTTP. I will listen to SMTP messages. I will listen to this. I will listen to that. All of that can be specified for the same set of services. I can create multiple concrete bindings for the same set of services. Right? So the main reason why this was done was to enhance reusability. The abstract portion can be reused. Certainly the concrete bindings would have to be recreated depending on how you want to expose it. Right? So this is just a pictorial view of the fact that this is a composite web service. Right, this particular thing is a composite web service. The description is given out, and the client can read the description and generate the appropriate stubs or access it in some way knowing the description. You can generate stubs, do it by hand, use the tools like we just heard, whatever. In this case, it is a composite description. So in each of the web services that this is going to hit, so travel reservation service, it would need a WSDL document that is specified here for it to come back, and it would do the same thing. So it's a very uniform model. Every time you hit a web service, you will prefer to start with a WSDL description. Same picture that you had seen earlier, right? So you register a web service. The registration of a web service to UDDI is also a SOAP request, right? UDDI is a registry, and we'll cover this tomorrow. But this is also everything is SOAP in here, so it's a SOAP request. Then your search request is also a SOAP request. So the search comes back with some set of services. And then you contact the server to get back the WSDL document, which is another SOAP request, and then you actually contact the service itself. Right? So what this mainly does is that if I have a WSDL description, I can have a program-to-program communication accessing that service. Right? So I can do it through two ways. If I exposed my service as a JSP, for example, then only a browser will be able to display what the result of that JSP is, right? And then you do something with that. It's meant for human-to-machine communication. But given a programmatic description, a formal structured programmatic description of my service, then it's possible to write programs on the other side that will be able to contact me and process the results as well. So it's discoverable through some registry. Because this description is standardized, I can put it out in a registry and allow other people to search based on different parts of this description. Right? It turns out that UDDI is actually pretty powerful by itself. You can search based on show me all services offered only by IBM, something like that. Right? I only want a specific provider let me see what services they offer. Or you can search based on different attributes. Show me all services that cost less than X, things like that. And so arbitration can be done. So given that there is a standard that I have published as to what my services are and how you can access me, if there is any, let's say there is an SLA violation of some kind, this third party arbitration can be done to say here was the specification and here was what actually happened, right? Because that is a public specification. I already put it out there. So here's a color coded document, the example, which shows the different structure. So there is something called types. So you first define all the common types that I am going to end up using, right? So these are the different parts of a WSDL document, right? And this is what you are going to create today afternoon, right? And we will create one such document and show this to you as well for the same example that you did yesterday, by the way, this groups and secret codes and stuff like that. Then there are the different messages that I can accept, right? Now these messages can be combined in various places. Every part of WSDL is set up so that it can be reusable in some other part of the document. It may possibly in many other parts of the document. So instead of just specifying an operational signature saying this is the operation, here are the input parameters, output parameters, whatever, I define this notion of input messages, output messages, blah blah blah, right? They're all different messages. And I can actually create an operation, right? I call it a collection of operations is called a port type, but I create an operation by combining many messages that I have just defined earlier. That's the notion here, right? And then finally I specify the bindings, right? So the bindings, once I specify the bindings, I will say that the service itself is accessible at this URL. The binding just says what is the technology you need to use to contact me. So what is the protocol binding? And then I say that this is a service name accessible at this URL at this port, finally, right? So those are the 5 or 6 parts of a WSDL message. So the WSDL namespace itself, remember the standard namespaces from which we would end up importing stuff, is available here. So you can import these schema into your WSDL document. Any questions? Okay. So the first part was the types, so the standard data type definitions. Remember your XML schema discussion that we had yesterday. So here is an example. Okay. So the whole thing is just a types definition. The rest of it is not here, right? In the types definition, so I am going to store this as some stock code.xsd. That's my target namespace in which I am putting this. So a trade price request is a type that I am defining. It's a complex type that is has a ticker symbol which is of type string. Right? In this case, it has a sequence. Is an all here. Remember, so it has a sequence of ticker symbols, each one of which is of type string. This is an implicit definition. Remember, we talked about implicit and explicit definitions in XML schema yesterday. Here's another definition that I have done. The name is called trade price, and the definition of this would be that it is a sequence of just prices, right? So it's a sequence of floats essentially, each one of which represents a price, right? So you could see how I can use this to expose a stock quote service that I'm going to run. So I'm going to get a series of ticker symbols and I'm going to send back a series of prices, right? That would be the obvious, but this is just a types definition, right? Then there are the different, the 3 other parts of it. There are messages, right? Messages are just the type definitions of the XML information sets that are being exchanged. We'll see examples, and their operations, and a collection of operations is called a port type. Every operation can be either an input operation or an output operation as far as the server is concerned, right? Every message can be an input message and output message. A collection of these would form an operation. A collection of operations would form a port, which is just that organization. So the port type is the abstract definition of the service. So I make it concrete by specifying a binding, right? And then I say that the service is running somewhere, and therefore that's how you can access it. Okay, so we'll continue that last example that we had. So I have 2 different messages. Get last trade price input is a message, that I am defining, and this essentially has the trade price request. So I had defined this trade price request here, right? So the message takes, so the message has as its body the trade price request type, an element of that type that I have created. All right. There is another message that I am defining called get last trade price output, which is simply returning something in the body that is of type trade price, which is a sequence of floats that I had defined earlier, right? And then my port type that I am creating has only one operation in it. It can be a collection of operations. Remember, it's like a class having a set of methods. Right? Each method is being defined as a set of messages, input messages and output messages. Right? It could be more than that as well. We'll see. But so it's very similar to that. A port type is like a class. Right? So here there is one operation called get last trade price, and get last trade price has two messages, one an input message, one an output message. Right? So given a get last trade price input, which is just a set of ticker symbols that is coming from somebody, I am going to send an output message which is a set of prices. Right? So that's my stock quote service. Then there is a binding. We have not yet talked about the binding aspect of it. So it can be specific protocols and data formats. So there's the different parts of this.
Very simple, like the stored procedure in and out variables.
Yeah, it's the same notion. It's just a way of defining it, right? That's all.
Is there any way to categorize the services?
Categorization is done in the directory. So you can create categories of services in the directory. So for example,
domain specific category.
Pizza delivery service. All the pizza delivery services are sitting there. Flower delivery services are sitting somewhere else. HR services are sitting somewhere. Is that what you mean by categorization? Yeah, you can do it in the directory, not here. So when you put it in a directory, when you put it in UDDI, you will put it under some category. And you can search by category on the directory. The service itself has no notion of a category built into it. It's just how you put it in the directory.
No, sir. You said that a SOAP message is to be sent to the UDDI registry to register this WSDL. So, to putting this our WSDL under some category, can it be automated?
It can be automated. Depends on what you want. Certainly, it can be.
In that case,
so in fact, what
you need to send a category flag with the this WSDL SOAP.
Right. So there will be a protocol exchange that is message exchange. First, you will query the UDDI directory saying what are all your categories currently. Right. You will get that back, and you will pick the appropriate category, whatever that happens to be, or you can search for a specific category if it is present or not. If it is, it will show you in the hierarchy where that is present. Right. If the category that you want is not there, you have to create a new category, right, and then put the service under that category.
So this is all manual process.
There is a manual or automated. You can write code to do it. Most certainly you can write, because these are all SOAP messages at the end of the day. So you can write.
At the registry level.
Yes, categorization is at the registry level. That's in simple. That's what it means. Right. Can it be automated? Yes, it can certainly. If all the services that you as a company are putting out have to do, let's say that you are going to offer manufacturing services for some die cast metals of some kind, then every service you offer will have to do with that category. You know that. So I can write out in a configuration file saying every time I deploy a service, please go to UDDI, and if the category is not there, create the category first and then keep dumping all these services under that category. I can do that. It's not hard to do. Okay, so this we have seen. So here is the same example continued. Now we are sticking a particular type of binding here. So we are saying this is a document binding. So we are going to exchange documents. XML documents is the thing. And the transport that we are going to use for this binding is HTTP, right? So this is a HTTP binding essentially. Now for each operation you can also specify the types of encoding that you can use. It can either be literally XML or some other kind of encoding. Remember we talked about this earlier as well, right? Then finally I am going to set up a service. I just call it my first service. It can be anything, right? The name is called a stock code port, right? But it has a specific address. So http example.com/stockcode. If you come to me here, and I will be able to understand the messages that I specified earlier, right? So this is the place where you should send these messages if you are using HTTP. That's what I am saying. Finally, right? Now I can just as well define a different kind of a transport, right? And there are different kinds of encodings that are available as well. But you will have these different combinations that are possible eventually. That's what you will end up creating, right? So here is a more pictorial view of the same thing. That was the XML view, right? So this shows that, of course it is not for the same example unfortunately. There are all these foos and bars and XYZs in here. But a service is made up of a port and a particular binding that is associated with that. The different port types that are associated with that, and every port type is made up of a bunch of operations. This doesn't show the messages itself that make up an operation. It's the same thing, right? So many services can listen at that particular listen point also, right? I can deploy many services in the same listening point. This is another view of what we have seen several times before already, right? So yesterday somebody asked me about sending images in SOAP messages, right? Yeah, SOAP messages, see XML has remember the XML schema has a data model, right, associated with it. XSD:int is an integer, XSD:string is a string, etc. Like that there is something called XSD:binary, which basically says here is a binary object, and then you can describe the object saying this is a JPEG image, GIF image, whatever. It's a video that I am sending, etc. So that's one way of doing it. It can actually be included as an XML data type, standard XML data type, which is part of your type system in here. That's you can also do it like that. Okay, so the message element consists of many logical parts. This is actually the XML schema for the message element. So remember, you are creating specific messages. You are not writing the schema. You are writing an instance of the schema that has been defined somewhere else, right? And so keep the schema in mind. We'll take a look at an example. So what this is saying is that for types, right, we are going to define different types. So this is a message. So let's start from the bottom here. The message name is a PO, and it has two parts to it, right? The first part is of type PO, TNS:PO. The TNS:PO is defined here earlier, right? And this the PO type itself is consisting of a sequence of ID, name, and a sequence of items. It's a purchase order for many different types of items that are going to be bought. Right, and every item is going to have some item name, min occurs, max occurs, whatever, right? It's unbounded max occurs, so it has to be at least 0 items that are part of that PO, is what this is saying. So this is the definition of the PO type itself, right? Then every item is also further specified here. It has a quantity, it has which product, and so on and so forth. Then there is also another part to this message. The second part is composed of invoice, and this is of type TNS:invoice, that is defined somewhere else. TNS:invoice is defined here, TNS:invoice type, and this has a sequence of just strings, as it turns out, right? So this is a types definition that you are doing within your WSDL, and in your types definition you are going to reuse these types in the different messages that are going to be created. Right, so there is a definitive structure to how you can create these types and how you can use it in messages, and so that structure is described by this XSD that is available for you at W3C as part of the WSDL XSD. That's the notion, right? Okay, so there are different types of operations that are also permitted. They are one-way operations. The endpoint is just receiving a message. Request response operations is the standard request response. A correlated message is sent back, and there is notification operations where the endpoint sends messages. Right, so this is the one request multiple reply kind of a notion. The one request multiple replies, I register for notifications and I keep getting notifications. So every time stock price changes by 5%, send me a message. Right. So I will do a one way first, saying that register me for this service, and then there will be a notification message that is sent back periodically until such time that I end up cancelling my registration. That could be another one way message. Right. So here's a one-way operation. There is only an input message that is associated. This is why we separate the notion of messages and operations. Right? Very different in an RPC. It's always two-way. We know that. There is no choice about it, which is why it is structured differently. Here we have different choices. Right? Okay, so here is a request response. It has input messages, output messages, and a possible fault message that can be returned if the output is not going to occur. Right, so there is a purchase is the input message, a confirmation, and whatever fault message we want. And the message itself is defined outside of this. The operation is a collection of messages, how we put it together, remember. Right? So in the case of notification, there is only an output message. Right, which means that the client will expect these kind of messages to come to you. So if you have a WSDL and you see a operation called delivery status and it only has an output message, it means that you will get pinged if you have registered before, presumably, and expect these kind of messages to come to you, and then you will have to be able to process them on your side. Right? Okay. So one of the things that it is highly recommended that you do is that you create reusable definitions as much as possible. Type definitions are presumably reusable in many situations, so you create actually a separate file that has type definitions. Don't dump everything into one large WSDL file. Right? So this is the monolithic versus componentized notion that we went through yesterday. And then you create all your other abstract definitions of operations and port types and keep it in another file. And then you create bindings in a third section, because there can be many bindings that are possible for the same abstract definition of a service, and so on. And you use import element to import the necessary parts of the WSDL. So here's how you would do that. Yeah.
Is it possible that a service multiple outputs?
Yeah, your message basically can have multiple parts to it. Right? You can return as many things as you want. Oh, certainly. We saw that, right? Where was that? So this is a way by which a message has multiple parts to it, right? And each one of these this could be an output message. This PO could be an output message, which means it is returning stuff or coming back in the other direction.
And then we will be receiving it in some local variable of that client who is accessing that service.
Yes.
It will be received in terms of some array.
No. This is not necessarily true. So there would be a WSDL description. The WSDL description in this case is saying that if you are going to get back a message of type PO, there is going to have two parts. Each part is going to look like this. The first part is going to be of type PO, right? A type PO is described here, right? The second part is going to be of type invoice, which is basically a sequence of integers, a complex type that is a sequence of integers. Now knowing this description, the client will generate an appropriate stub to receive such a message. Right, what will the stub be? The stub will basically create a structure of some kind. Right, it will return a structure instead of an array. The structure would be a sequence of PO items or something like that that's here. So this is a sequence, and then internally there is a sequence of items, right? So it would be a structure of structures of some kind, right, that is set up on the client side, and that data structure would be returned to the client program to do something. Right? That's how your stub will generate it. If you use Java, they would all be classes.
So in continuation to what?
Yeah.
It means suppose if there is an operation here defined, and within that operation we have mentioned to generate an output message. In that case, the stub which would be generated will have a method with parameters.
Yes.
So the question is probably if the parameter, can it have an array?
Yeah, any data type that is supported by an XML schema, you can create with this.
So can we have array of messages defined here, sort of way? Because then only it would be, the stuff which would be generated will have that in parameter, or say the out parameter in form of multiple values.
No, why would you need an array of messages? What you need is a message that will send back a number of things. It may send back an array, it may send, in this case there is no notion of an array in XML schema definitions, there is sequences. You can send back a sequence of stuff. A sequence of things will get translated to a list probably on your client, on your this thing.
Here, the entire input message is treated as one entity.
Yes.
And in processing this input message, you can use the array method to distinguish the parts of the message. So that arraying, putting this entire input message, specifying it in WSDL is not a proper place. Whereas processing of input message, for that you need an array.
No, that I understood. My only question was that group of messages will become an operation. We are defining it earlier that this is the operation has one input message, one output message. That message again has a, if I'm not wrong,
It can have one input, one output, or just one output, or just one input. We saw the three different types of operations. Yeah. Any comment.
That would be, stuff would be generated based upon that whatever we are defining
Correct.
here. So it would be converted, it would be translated into a method which is having parameters.
Correct.
Message is ultimately a parameter. So the parameter again, whatever we are defined here, the message.
No, it's not one parameter. Yes, message can't, yes.
It can have a number.
That's right. It can have a number of parameters, it can have a complex structure as a parameter that can in turn have many sequences defined in it and so on. But your definition is mainly limited to what the XML schema definition data type model gives you, which is actually pretty flexible as it turns out. You saw that yesterday. It's a fairly flexible model. Right?
I understood as you said that sequence of messages.
Right. So that.
Operations, there are two messages inside. The previous one.
This? No.
Operation is having two messages. And there's two messages. One is input and the second is output.
Right.
So that means it will be one XML file. Ultimately it will be a single XML file. Contain the parts of it as an output.
The output would be an XML SOAP. It would be a SOAP message containing the body that looks like this.
Yeah.
That's what it means.
Yeah, but ultimately it is an XML.
Yes.
Ultimately when we are accessing it at the client.
No, it depends. That's what I'm saying. If you use a stub generator, it will give you a programming language API. It won't give you an XML API. You don't have to use a DOM parser or anything like that. Okay.
Now, whether it can be two output messages.
You can have any number of output messages. Then your client has to be prepared to receive all these output messages and correlate it to the single request that it sent out. You would want to do that. It may get a little confusing, but you can do that. It gives you the flexibility this gives you the freedom to hang yourself. That's the notion. It's like C, right? You can manipulate every bit of memory in C, but you'll probably get into so much trouble that your program will never run. So it's kind of the same notion. It's very flexible. You can have multiple output messages. All it means is that if I send a single message, then many messages are going to come back to me in return. That is in fact what the notification is going to be structured as.
So many messages will be coming back, or it will be one message. So that's what my question is.
It can be either depending on what you want.
Because
In this case, for every request, one will come back. That's what it says. If it says for every input, one output is going to come back. If
every operation will be sent.
For this operation, this operation can accept one input message, and for that input it will send back one output. That's what this means.
So one more output is it means that will be two messages.
Yes, for every time I receive an input, I'll send out two messages, is what the other thing would mean. Which is possible. You can do that.
Sir, yesterday for one of my questions, you replied there is a standard for semantic representation. WSDL semantic is there. So
Owless. WSDL with Owless.
WSDL-S or semantic annotation of WSDL.
Semantic, that is called Owless with WSDL. We won't discuss that in the course. It gets really hairy to get into the details of that. There what happens is, basically you want to explain the meanings of certain terms. right? So what does it mean to say PO? What does it mean to say item? What does it mean to say price? Does it have some meaning associated there? Is what I mean by price the same thing as what that person is meaning by when he says price? How do we know that? We tie this information through ontologies, right? So an ontology would be capturing these meanings in some way. WordNet is one such global ontology that is available for the English language. And you say that what you include here would, instead of becoming names, it would become concepts in an ontology. Right? So you say that by price, it is tied to this concept in this ontology. That's what price means. So if somebody else were to look at the word price, and you would say, wait a minute, so is it the same meaning that I am looking at? Right? So in fact, you can have different ontologies too. And you can have mappings, equivalence mappings between these ontologies. Right? So it can figure out whether you are both talking of the same thing or you are talking of different things. That's what we mean by semantic information. And so the integration of ontological equivalence is put into WSDL with the semantic versions of web service. That's a 5-minute explanation for what will be a whole course by itself. Any other questions? Okay, so this is what we were saying. Here is the example of trying to keep things separate. Right, your type definitions are being done into some target namespace here. The target here, target namespace is this. In schemas, I am going to store my different type definitions. I have type definitions, two of them, trade price request and trade price, right? And trade price request actually takes a sequence of ticker symbols, each one of which is a string, and the same thing that we had seen before. Trade price is a sequence of prices, which each one of which is a float. All right. So now I have a different file. Right, this is a stock code definitions file in which I am getting these schemas from somewhere else. So I am going to refer to these schemas as in this namespace. XSD1 is the name for where I am going to refer to these types. Then I use XSD1 : trade price request and whatnot. Right, so essentially the notion is that if I wrote a different service having to do with stocks, show me trading volumes for some stock code. Right? Clearly for the stock ticker symbol notion can be reused everywhere. It can be trading volumes, it can be intraday volumes, it can be trends, whatever. Right? So the notion of a stock ticker symbol can be reused, as a result of which I say is I am going to reuse this. In fact, this is not a very good way of reusing. Maybe I will call it a ticker symbol itself, which is a string. That's one way of doing it. But anyway, so this is one example. Right? So that's what we've done. We did types first, and then we defined the messages, operations, and the port type in a different setup, in a different file even maybe. It's better to store it in a different file which encapsulates your definitions. Right? Here the target namespace is definitions. Right? This was schemas earlier. Now we have definitions. Okay, so you import your stock code schemas and then use it. Define your port type. Then finally, you are going to create the stock code service.WSDL. Right? In this you need the definitions, because I am going to reuse the definitions, and the definitions in turn will use the schemas or the type definitions that I created, the types that I had created. Right? So I am going to import this namespace and then use it here. Actually, I should have had an import. Oh, I do have an import here. Okay. It's all in red there, but here it's clearly outlined. Okay, so this is what you want to be doing, rather than try to mush everything into one humongous structure, explicit versus implicit, so that this notion of reuse can be pushed to the limit. Define the bindings and the different services. So what are the different WSDL bindings itself? Basically defines the protocol details and the message formats for the operations and the messages that are defined by the port type, right? For each operation I can have a different binding potentially, or I can have multiple bindings for one operation. It's also possible to do that. But it's better to treat a collection of operations as one entity. The port type is our best abstraction, and to go with the port type itself. Right? So you can specify one out of these. If it is SOAP, is it SOAP over HTTP, SOAP over SMTP, or HTTP get or post? Right, so you can just go the plain old HTTP get or post, and there is. So this is again the XSD or the schema for the binding aspect of it, right? So this is what your eventual WSDL file would have to conform to this particular XSD, right? Whatever you end up writing. So you're saying we'll take a look at an example. Okay, so here's an example. The binding extension syntax is basically whether, apart from specifying the fact that you are going to use HTTP or you are going to use SOAP over HTTP, SOAP over SMTP, you can specify whether it's an RPC style of communication, whether it is just a document style of communication, and you can specify different encodings. Is it literal? Is it encoded in some way? If so, what is the encoding style for the input itself that this particular operation is going to contain, and so on. Right? So for each part of the operation, you can specify a different encoding method. So essentially, remember what the encoding method will dictate is how the on-the-wire contents are going to look. Right? So here the operation, the two choices here are RPC and document style. Encoding method has the use variable has literal or encoded styles. Right? So though you can have combinations of these, you can have RPC with use equals literal, and you can have document style with use equals literal, and the other two combinations are also possible. Right?